So, ladies and gentlemen, we are starting right now our first session for math. But I think after some minutes, we are going to have a 3 minutes break. Then we'll come back and finish session one. Then after that, I think 19 hours somewhere there, we are going to have our session two. Okay. So for the first session, it's going to be based on sets and a bit of functions. Okay. So there we go. We have the first question, which is coming from the set interval notation. One thing you should understand is that there is no test and there is no exam without this question. So you should be familiar with this question because any test, any exam, this question has to be there. Set interval notation has to be there. So there is 90% chances that this question can come. Let u be equal to the universal, which is negative 5 all the way to 10, and set a is negative 1 to 6. 6 is included, but negative 1 is not included. B is 0 to 4, both not included. C is telling us to say x is a member of real numbers, but it should start from negative 4 all the way to what? To 7. Okay? Now, it's saying illustrate each of the following sets on the number line, hence or otherwise. Hence, find each of the following sets. There we go. The first thing that you have to do is to draw the universal. Here is my universal. Now, this universal is different when they tell me to say the universal is all real numbers, where it starts from negative infinity all the way to positive infinity. In this case, we have been told where to end. Okay. So then the last part I have to put open because negative 5 is not included. I'll put negative 5 here. And then here I'll put also open because 10 is also not included. That is my universal. Let me put u as the universal. Now, the first thing that I want us to solve is a minus c. But before we do that, let us first dismantle c. So c is telling me to say it is starting from negative 4 ending on positive 7. Since they are using less than or equal to both, meaning these two guys are included, meaning that in simple terms c is actually starting from negative 4 all the way to what? To 7, and both are included. Now I can start. I have negative 1. I'll put negative 1 here. I can put 0 to show that this side they are negative, this side is positive. But even if you don't include 0, that's not a problem. I'm going to put negative 4. The positive part for a and c, I have got 6 and 7. I'll put 6 here and I'm going to put 7 there. The first thing I'm going to deal with this guy, which is saying a minus c. Minus simply means the next guy need to have a complement. So it's basically the same as a intersection c complement. It's more like I say 2 minus 1 is 1. So in 2 we are removing 1. So in a we are removing c. That's why it's a intersection c complement. Now I need to draw a because in a there is no complement. So a is going to be the way it is. Starting from negative 1 not included all the way to 6. 6 is included. That is my a. I'm going to put a line to show that this is my a. C complement. Initially, c is starting from negative 4 all the way to 7. But because it's a complement, c negative 4 is included, meaning that the complement part of negative 4 is not going to be included. It will go all the way to negative 5. That is the first c complement. Another one starting from 7, since 7 is included, then the complement part will not be included all the way to 10. Again, that is C complement. Meaning that from this point here all the way to that point, that is my C. But I don't want that line. Does that make sense? We want a part where C complement and A intersect. You are too quiet, guys. We want a part where C complement and A they meet. Do we have any part where these two guys meet? So what will be our conclusion? So what is the answer? Empty set. So in this case, I will report that A minus C. I'm finding. You can mute your mic when you respond? Then you mute your mic. We are not finding A intersection C. We are finding A minus C. So you report that A minus C is equal to empty set. Using the number line and also showing them that that is the answer. It's done. Without wasting much of our time, let us go to part 2.
So the screen has been disturbed. I don't know what's happening. You can see.
Everyone is experiencing the same.
We're seeing someone's phone.
Nizamchosa huyu. Okay, we can continue.
It's fine now.
Okay, so then let us go to part B. Part B is B complement intersection C. Then in the brackets we have this. So just brings complement inside, which is going to be B complement complement union C complement. Complement and complement will cancel. I'll have B union C complement. So as usual, let's do the same thing. We said that C complement, it was starting from here going this side, then again starting from there going this side. That was our C complement. Now let us go to B. B is 0 all the way to 4. Both are not included. 0 to 4. I'll put 4 here. So 0 to 4. Both are not included. Now, if I want to, I'm talking about union. Who can tell me the answer? So B complement union C intersect complement here. What would be the answer? This is now union, not intersection. Let's do fast. Let's do fast. Let's do fast. Mm-hmm. That's the answer, 0,4. Okay. Starting from, we are talking about union. So union, we want everything here. Then when we reach here, we'll jump, getting this part. When we reach there, we'll jump, getting that part. So then it will be -5 all the way to -4, not included union. 0 all the way to 6, not included union. 7 all the way to 10, not included. That's the answer. Unless you have got a question. Unless you have got a question. Okay, let's do the last one, which is going to be. Oh, it's supposed to be 4. Thank you. It's supposed to be 4, not 6. Yeah, it's supposed to be 4. Thank you. So we can now do part 3, right? Because if we do part 3, I believe you can do, this one is very simple. You can do this one and this one. So you are going to do this one and send me the answers. Okay? Let's do part 3. Again, we are starting from -5 all the way to 5, all the way to 10, not included. That is my universal. Then we can put 0 here. What else do we have? We have got -1. In negative side, we have got -1 and -4. Positive side, we have got 4. What else? We have 6 and 7. Since we are dealing with 3 of them. So then this is the same as C intersection A complement, then intersection B, like that. In simple terms, I'll start with C. No, let's start with A complement. Initially, A is 0 all the way to 4. It is not included, meaning that the complement part will be included. So starting from this point, going to this side, included, that is A complement. I'm talking about B. So A is starting from -1 all the way to 6. -1 is not included, meaning the complement part is included. So starting from -1 going to 5, -5. So that is my A complement. Again, since it is reaching on what? 6. 6 is included, the complement is not going to be included, going this side. So that is A. Sorry. So it's A complement. So we are excluding -1 to 6. So we don't want this part. This is A. So we're talking, this is A. So we're talking about A complement, which is, we are excluding that part. So let us talk about B now. What is our B? Our B is from 0 all the way to 4. So 0 all the way to 4. Both are not included. That is B. C. C is from -4 all the way to 7. Both are included. -4 all the way to 7. Both are included. We go there and put it like that. That is my C. We want a part, since there is intersection inside, there is intersection outside. We want a part where all these 3 guys meet. So I can clearly see that where these guys meet is here, the 3 of them, not the 2. Yes, you can ask.
We can't get you clearly. I don't know if it's my network or there.
Everyone is experiencing the same.
No, sir. It's just okay.
Try to leave the meeting and then rejoin. Now if you leave, meaning you are gone, another person will join. But you can leave and join fast. So we want to find the point where all A complement, B and C, they meet. Do you have any point where all of them, the 3 of them, they meet?
Yes, we have.
Which one is that?
Yes.
Which one is that?
No, we don't have.
We want a part where all the 3 guys meet. Do we have any? We don't have.
Yes. No.
Which one, madam? The madam is. Which one, madam?
We do. Is it not from -4 to -1?
We don't have.
From -4 to -1.
We don't have B there.
No, we don't have the part where all the 3 are meeting. Oh, where all of them we don't have.
Yes, so we don't have. So then, what will be our conclusion?
It's an empty set.
It's an empty set. So we go there. You guys screenshot this. I want you to send me the answers for this guy and this guy. Not Yaka. So I want to tell you the truth. This question you need to take it seriously. You can mute your mic, mute your mic, mute your mic, mute your mic. You need to take this question very seriously because tomorrow, the time you're going to have exam and quiz and test, this question should be there. These are the most important questions under set theory. So understand this. Another set of the question that you need to know is this one. There will be no test without this question. Even even if when you go through the past papers, you'll be able to find this question in both test and exam. So express each of the following in a form of a over b where a and b are integers and b is not equal to 0. Give your fraction in its lowest term. Let's begin our discussion with the first one. So the first thing, just after the point, if there is a bar, then we say x is equal to the same thing. Write the same thing the way it is, 8.4, like that. The next thing, move the bar from this point all the way 1 2. That would mean to say is hundreds, two zeros. 100x will be equal to, now this is 814.14 bar, meaning that it keep on going 141414. So I'll put again 14 bar, then do minus. In most cases you are going to have challenges on how to do minus direct. Put the bigger number on top, the small number down. But even if you do direct, you still have, you are going to find the same answer. What I mean is, put,
So me, I can see the screen.
you can't see the screen, leave the meeting and join again. So it will be 100x is equal to 814.14 bar. Then this is going to be x is equal to 8.14 bar. Now you do minus. If you want, you can do direct from here, it's okay. But to avoid confusion and mistakes, put the bigger number on top, the small number down. So 100x minus x is 99x, right? Then this one is going to be 14 minus 14 minus 8 is 6, eh?
Yes, it's 6. Yes, I 6.
6. Then what are we going to have? We have borrowed 1 here, so here there is 0, so it's 806. Divide that by 99, divide by 99. So x will be equal to 806 divided by 99. Now, the question here is this. Give your fraction in its lowest term. So we need to find a number. If there is any number that can go into 806 and 99, then that is okay. What number should we try? So you look at the bottom number. It's 99. Maybe let's try 3. Okay? So if 3 will not go into 806, then I think it should end there. I don't think there is any other number which can go into that. Not so. If you feel like
Yes.
if you feel like time is not with you, don't even waste time thinking, end there. You know, whenever you're talking about math, you need to be very much fast and accurate. Because tomorrow, the test you're going to have is not going to be hard, but time. We need to be very much careful with time. So let us now do the one for negative. So I believe the way we have solved this one, you can solve this one. Now I'm going to solve this. If I solve this, you can be able to solve that. Then we'll solve that together. So this one now, there is a number which doesn't have a bar, which is 5. That would mean to say the first thing you have to shift the bar, or you have to shift the point to the nearest bar. So it will be, you have moved once, so it's times 10. So it is now 10x is equal to negative 45.23 bar. The next thing, starting from the same point where the point is, sorry, you move all the way 1, 2, 3. that would mean is 1,000 is going to be equal to negative 4523 then 0.23 bar. Like I said, if you want you can do direct or you can switch them. You can put this number on top, then put this number down here, negative 45.23 bar. Then now you can do minus. So if we do minus 1000 minus 10 is 990.
Yes.
So we have 990x is going to be equal to, so here we start from these will give us 0. So we'll start with 13 minus 5. What is 13 minus 5? It should be 8. We have 1 here, so now it will be, we borrow again 1, it will be 11 minus 4. Oh, we have negative here, right? So the answer will still have negative, not so. This number is big.
Yes.
So we have got this negative and this negative will give me positive, but it's still minus. But because this number has got bigger, it has got negative and it's also bigger than this guy here, and we end up having negative. In short, in simple terms, if any question has got negative, your answer will still have negative. If it doesn't have negative, it will have positive, just like that. You follow the same thing. So we have 11 minus 14, or 11 minus 4 is going to be what? 7. Then I have remained with 4 here, so I have negative 4. So I think we have not made, is there any mistake there?
No.
So 4478. Let's divide everywhere by 990, even here 990. So x is equal to negative 4478 divided by 990. If at all there is a number which can go there, then you can do it. Do you think 2 can go into 990? Yes. So I think I can use 2 because there is 8 outside here. 2 goes into 8, so I know that on top there 2 is going to enter. So let's do 2 into 2, or 2 into 4 is 2, 4 again 2, 2 into 7, 3, then into 18, 9, 2 here, it should be 495, eh? Again there is this number 9 and also this number 5. If I want to try any number, I can try 3. If 3 will not go, then it will end there. The reason why I'm going to use 3, because 3 can go into 9, again 3 can go into 15. So then I'm going to try 3, but I don't think 3 can go into 495. I don't think so. Yes, it goes. Not so. Have you seen the way I'm able to know to say I can use this number here to divide?
Yes.
So now I'll start with 3. On top there I don't know, but down here I know the answer. So 3 into 4 is 1. 3 into what? Remainder 1, right? Into 19. So it will be 6, remainder 1. Then into 15. Then into 15 is 5, right?
Yes.
So on top here now again 3. So we'll say 3 into 20. We'll say 3 into 22. 7 remainder 1. Then 3 into what? Into 13 is what? 4 remainder what? Remainder 1. So 3 doesn't go there, not so. So the answer ends there. Let's not waste time. So it ends here. Then another part that is confusing a lot of people, but not you, but those people for a long, long time ago, is this one for minus. So you guys go ahead and do this, and also that one. So let's do this one. This question is very simple, such that we should know that this guy which we have here, if I want to put it in fraction, what is 0.25? I want to put it in fraction. 1 over 4. So, okay, yes, you can say that. So 1 over 4. So now I'm going to leave it here. I'll deal with this one first, the fraction that I'm going to have here. Then I'll come and say minus 1 over 4. So we know that the first thing will be x being equal to 9.42 bar. Then now we push this one 2, which is 100. 100 is equal to this 0.42 bar. Next, I can do direct if I want, but because let's do minus. So 100 minus 1 is 99, eh? Then 12 minus 9, 3, eh? We have 3, we have 9. Is this correct?
Yes.
Divide it by 99, 99. But now, because you can mute your mic, because we have got 3 here and 9 here, I believe 3 can go. Mute your mic, mute your mic. So 3 into 9, 33. Into 9 is 3. 1 there is going to be 1. Then here it will be 3, 3. Is there any number which can go into that now? Can 3 go there? Okay, let's leave it there. So I'll say 3, 1, 1 divided by 3, 3 minus now this 1 over 4. So the common denominator is the same as just saying this times this, which is what? That is going to give me 12. 2 carry 1, 12, then it will be 13. I don't know if I've made a mistake. Indeed supposed to be.
That's the answer.
Are you sure? What is 33 times 4?
8 times 4, that's 4, 13. 213.
213.
Yes, sir. Yes, it should be 213.
Okay, 213. I'll put it here, 213. So then what we should know is that 33 into this guy, because we this is simple now. Because we did this times this, when you are 33 into 213, it will go 4 times.
Not 213, sir.
It's what? 132?
Yes.
So 132, 33 into 132 is 4, because we did times here. So 4 times 3, 11. So 4 times 3 is 12. So we write 1 carry 2, right? Then 4 times this is going to be 4, 2, so it will be 6. Then 4. If I've not made any mistake here, I think it should be 164, right?
No, sir. It shouldn't be 164. It's supposed to be 1000 something.
Ah, are you sure? 4 times 130. Oh, yeah.
Yes, because that's 4 times 1,
Yes.
that's 4. 4 times 1, that's 4.
So 4 times, okay, let's start with 4 times 3 is 12, right? So we write 1, carry 2, then 4 times
1, 4. 4 times 1, 4. So it's
1200. 1204. Oh yeah, okay, 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 okay. Minus then 12, there it will be 33. 33 times that is just that, right? Then what? 1244 minus 33. Ah, guys, this is the same as this. 1211 divided by 132. 132. You know, don't even waste time. If you feel like you can just end there. But if there's a number, if you know that there's a number, but stop thinking. Because in math, if you start thinking now, start looking for the number for about 5 minutes, you are wasting time. If I can't find the number, if I can't find the number, stop wasting time. Leave it just like that. They are going to give you marks. So this one we should know it, guys. It's very important. Another set of the question that you need to know is this one. Now this one I believe is simple for you, but I'm going to solve two questions only. Let me solve 3 and 2 or 3 and 1. They look a bit complicated, but they're not hard though. I believe these other ones we can do, right? So 3I divided by 1 plus 1 divided by 2 minus I. Mute your mic. From here, what I'm going to do, there are two ways of killing a rat, or there are too many ways of killing a rat. But what I can do, I'm going to use the simple method. Is either I can get the common denominator direct, or I can get the conjugate both sides. What I mean is this one will remain the way it is, plus 1 over 2 minus I times, then this one will be 2 plus I, 2 plus I. Not so. So 3I plus, if I do times, on top there is 1, so nothing is going to change. I'll have 1, I'll have 2 plus I. Down here, 2 minus I multiplied by 2 plus I. Anything, if you're multiplying anything by its conjugate, there is a simple method. There is no any mark that is going to be given to you by doing 2 times 2, you write here 4. 2 times 1, you write here what? Times I, you write here 2I. Negative I times 2, you write here 2I. Then again you write here negative I squared. There is no any mark for this step here. The best thing you can do, guys, is if you're multiplying anything by its conjugate, we square the part having negative. In this case, this guy has got negative. I'll say 2 in the brackets, I'll square it, minus I in the brackets, I'll square it, which is going to be 4 minus I squared. So this, I have now expanded that. Should I repeat myself?
Yes, sir.
If you're multiplying anything by its conjugate, stop wasting time expanding it the way you expand. The best thing what you can do is get the part having negative. In this case, this is the part which has got negative. So what I'm going to do there is I'm going to square the part having negative. Put them in brackets, square this guy, don't touch this minus, then get to the next guy, put it in the brackets, then square it. Then you end up having this. This is the same thing even if I expand this normal way. Let me show you. 2 times 2 is 4. 2 times I is plus 2I. Negative I times 2 is negative 2I. Then that will give me I squared. These they will give you 0. Then it will be 4 minus I, which is the same as that. You get my point, right? So then I'll just come direct here and say this is 4 minus I squared. Then I'll have 3I plus 2 plus I divided by 4. Wherever you are going to find I squared is negative 1. So you replace it with what? Negative 1. The next thing that I need to know is 2 plus I divided by, this is going to be now 5. Not so. So here there is 1, remember. The common denominator is 5. 1 into 5 is 5. 5 times 3 is 15I plus 5 there 1. So I'll have 2 plus I. 15 plus I is 16I plus 2 divided by 5. They are saying leave your answer in a form of A plus IB, meaning that IB has to be to the other side. So this is the same as 2 plus 16I divided by 5. But we want to leave this guy to be independent. So it will be 2 over 5 plus 16 over 5I. This is the answer. Unless we have questions. Ask, 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 ask.
If I say A plus, leave your answer in the form of A plus IB. What if your answer between the real number, the real and the imaginary, there's negative?
It's
There's
fine.
a problem.
No, there's no problem. It's fine.
Okay, thanks.
Yeah, yes. So it can be either negative or positive. Okay, if we are good to go, then we can quickly go to question 3, and I believe you can do part 2. What if they cancel math tomorrow again?
I heard that it is cancelled. Yes, I will heard that mathematics class is cancelled. Test, I mean, is cancelled. Not 11:20, but. So you guys for 11:20 are not doing the math class. Yeah, it's on. It's on. But I heard that as for 1100 is not there, so we are not going to have the test.
Okay, that's good though. So that you prepare more notes.
Yes, sir. Yes.
When are you guys closing?
11:20 we are writing.
What time are you writing by 11:20?
9 hours.
Okay. Okay, let's do this first. Then we jump to. You can mute your mic. You can mute your mic. You can mute your mic. So let's now do this one. So this one now I'm going to expand the normal way. So 3 times 2 is 6. 3 times 3. Mute your mic. Is 9. Then negative I, that is going to be 2I. That is going to be 3I squared. Who is behind on how to expand this part? The top part. Who is behind? Okay, so 1 plus I. Then now we know that I squared is equal to negative 1, so it will be 6 plus 9I. But this one, 9I minus 2, is basically 7I. Then minus 3 times negative 1 divided by 1 plus I. So it will be 6 plus 7I plus 3 divided by 1 plus I. So then it will be 9 plus 7I divided by 1 plus I. When you reach at this point now, you can do times the conjugate, 1 minus I, 1 minus I. Then we can clearly see that, like I said, the top part you are going to multiply the way it is. 9 times 1 is 9. 9 times I, negative 9I. 7I times 1 plus 7I. 7I minus c, or 7I times I, negative I is negative 7I squared. If I'm multiplying anything by its conjugate, square this part. So then I know that where there's I squared, I'll put negative 1. Negative times this negative, it will be plus 7. So I have 9. Negative 9 plus 7 is negative 2I, then plus 7, divided by 1 minus I squared. Who is behind?
Sorry, sir, I got the same question. Just asking what was the final. Sir, you are too fast.
What was the what?
The final answer. Just the solution for what? 21.
Question 1.
Yes, sir.
I've forgotten. I don't know. What was the answer, guys? I think it was. I don't know if it was.
2/5 plus imaginary was 16I/5. 2/5 plus 2/5. Okay, thank you. I appreciate your question.
I'm too fast. 9.
Yes, sir, you're too fast.
Okay. 9 minus. It's good that I'm too fast. So I can increase the speed, right?
Yes, sir, you can move at the speed of light.
So 9 plus 7 is 16 minus 2I divided by 1 minus negative 1. So 16 minus 2I divided by 2, because this is going to be plus. 16 over 2 minus 2 over 2I. 2 there 4, we know 8. 2 there I. This is the answer. So the one who was asking, you have seen now that there is minus, but here there is plus. So this is still okay. Okay, now we are solving this one. Rationalize the denominator. Isn't it the same question we are from solving?
No. No.
No, it's not the same, but it's similar. Okay, let's do this one. So this question, there is 12 here, but on top here there is not 12. There is 3, the square root of 3 and 2. Therefore I can't go ahead and start now dealing with 12. So what am I going to do? I'm going to choose between these two, the square root of 3 and 2. I'm going to get 3. Okay, why am I going to choose 3? 12 divided by 3, it is 4, meaning that 4 times 3 is 12, meaning it's going to be the square root of 4 times the square root of 3, because this is a perfect square. So if I use 2, it's going to give me 6 and 2. So both of them are not perfect square. So I need to choose a number between this guy and that noun. When I divide it, the number which I'm going to get, it should be a perfect square. So I've chosen 3.
Sir, can you explain again on the first part? I haven't gotten it.
On top here we have got the square root of 3 and the square root of 2. Down here I've got the square root of 12. I can't continue with the square root of 12 because it's going to confuse with what? 2 guys which are on top there. The simple method that I can do is I need to choose a number between the square root of between 3 and 2, which when I divide it by 12, the answer should be a perfect square. When we say perfect square, there is a square root of that number. Without using a calculator, you can find the square root of that number. So 3 into 12 is 4. The square root of 4 is 2. So then this is going to be changed to be 2 root of 3. Do I have to ask you that, have you understood? Or maybe I should just go?
Yes, we have understood.
Thank you.
Just continue, sir.
So 2 root of 3 minus root of 2 divided by 3 minus 2, the square root of 4 is 2. root of 3. So 2 root of 3 minus the root of 2, then I'll divide this by 3 minus, this is going to be 4 root of 3. Now I can go ahead and rationalize the denominator. I'll do times 3 plus 4 root of 3, 3 plus 4 root of 3. Now we can do times. So that should be your network. You can leave the meeting and join again. But once you leave, then you are gone. Another person is going to join. So root of 3, 2 root of 3 times 3 is going to give me 6 root of 3. This guy times this guy, I'll end up having 8 root of is like the square root and square root here. I'll have 3. You know this principle? If I do square root of 3 times square root of 3, the answer is 3. Or maybe you don't understand why we do that. That's good. So root of 3 times root of 3 is just 3. Then negative root of 2 times 3, it will give me 3 negative root of 2. What else? What else? What else? What else? What else? Negative root of 2 times 4 root 3 is negative 4 root 6. This and that is root 6. Down part, stop wasting time. I said you can square the part having negative. That's all. So it will be 6 root 3, then 8 times 3 is 24, minus 2 minus 3, that minus 4 root 6. 3 squared is 9, 4 squared is 4, 4 squared is 16, root of 3 squared is 3. So then the part having square root, let them be to the other side, and this 24 should start. So then I'll say minus 3 root 2, then I can now write this guy, plus 6 root 3 minus 4 root 6. Divide this by, this is going to give me, it's going to give me what? 1648, 16 times 3 is 48. Then 9 minus 48, it should be 39, not so? Negative 39. Negative 39. When I do that, negative should not appear on the denominator. I'm going to divide negative by everything on top there. So it will be negative 24. What do you mean, Sano? What do you mean, sir? So negative 24, I'm dividing. Yes. So the square root of 3, sir, times the square root of 3. What is 3 times 3? Hmm? 9. So what is the square root of 3? Oh, the square root of 9. That's the reason why it's 3. So we are dividing everywhere by 24. By negative, sorry. So here now it will be negative, here it will be positive 3 root of 2, then here it will be minus 6 root of 3 plus 4 root of 6. Everything now is divided by 39. So the way you have to leave your answer, it should be in a form of, I'm going to write this negative 24 divided by 39 like that, then plus 3 root 2 minus 6 root 3 plus 4 root 6, then divide it again by 39. If you want, you can leave it here, but other people will tell you to say you can also deal with just this and that guy. You can factor out other things here. You can factor out maybe negative 2 and then negative 2 root 3, but still you are just wasting your time. Even if you end here, no one is going to penalize you, they will still give you a mark. I don't think this question can come, but let's do it for the sake of doing it. Given that x and y are set, simplify as far as possible each of the following. So whenever you are trying to simplify sets, it's something that is not complicated as long as you understand simple principle. The first one, we know that it's going to be x complement union, then y, where there is minus, is going to be intersection x complement, then we bring that. Now we can bring this complement inside. When this complement comes inside, this guy is going to change. Even that one is going to change, but for now, I'm going to put this complement here outside. So it's going to be x complement is just x. So this will be now intersection, then y intersection x. Who is this person making noise now?
Switch off your mic, say, would them, Nchana.
Okay, I've kicked them out. So x complement, we are okay up to this point, right? Before we continue to the next step.
Yes, sir, we are okay.
Okay, cool. So then we know that here is going to be x intersection y. Now when this complement comes inside, it will be complement then union that. One thing I want you to know, there is what we call, they are not going to teach you this, but have you ever heard of absorption method, absorption law? If you can't see the screen, that should be your network, madam. So leave the meeting, join again, you'll be able to see the meeting.
Yes, I haven't heard about absorption method.
Let's wait for this girl who is complaining. Are you still here? Or you have gone? Are you back? I don't know if she's back. So have you ever heard of absorption method or absorption law? You haven't, right? Yeah, that's why I told you to say. Even data boys, they don't know about absorption law. So today is the day for you to know absorption law. So absorption law states that if you have got this guy x here outside, inside here there is also x. There is intersection here, there is union. Even the opposite, where there is union here and then there is intersection there. So absorption law states that you have outside this guy, but again it is appearing inside. The answer is the same guy x. So you didn't know about this, eh?
Thank you, sir. Thank you, sir.
Then
Explain.
there are those people who still don't understand absorption law. Then we go back to grade 10. So we use this method. Yes, there's another method I'm going to use. Listen, just wait. Yes, please. Mm. Yes. So if you don't understand absorption rule, then we go back to grade 10. We use the Venn diagram. So we have two things, x and y. So I want to show you why it is x. So pick any number, you just put 1 in 2, 3, then outside put 4. Now let's list a x. X is 1, 2. Then what is y complement? 1 and 4. Now let us now put the numbers here. What is x? X is 1 comma 2. Intersect it. Then what is y? Y complement union x is 1, 2, and 4, right? Have you seen what I'm doing here, guys? For those who are not understanding absorption law, have you seen what I'm doing? You're not responding. So now, the number that the no, you'll be able to understand the next question. We also have, I think, the same thing. So, what numbers can we find in both this guy and that guy, which is 1 and 2? Not so. The intersection. So, from what we have, this guy and this guy, what is 1 and 2?
It's X.
That's why the answer is x. When the what? Are you asking in the background? You didn't understand. Mm. Yes. It will still work. It will still work, but you are a bit wasting of time. But we want to work with time. But it will still work. Let's do this one. Which one can we do? Let's do C. You can mute your mic. Ben alina moma ben. Mu background mveka kye moma. Ben is with moma. Okay, let's continue. Ben, are you still there? Let's continue, Ben. So now, let's go to part C. Part C is telling us to say x complement. Why should I solve this? Is bit similar to this?
But some of us didn't understand.
Okay, it's fine. It's fine. So you understand that when this complement comes inside, this guy is going to change, right? So it will be complement intersection y intersection x. Then we have got complement here. But complement is just in x. Intersect it with I'll have y. But because this complement will come inside now, it is complement union x again complement.
Why double complement there?
Because there's already another complement. Now this one outside, we bring it inside is complement, they'll cancel.
Right.
We are okay now on this part, right?
Yes.
At this point, if you want, at this point, if you want, you can distribute, you can say x intersect it with y complement union x intersect it. Do you know the reason why I can't use this absorption law here? I said if So because inside I've got x complement, if I had x just, I would have concluded that x is my answer. But because there is x complement inside and outside there is x, those two guys are not the same. So I can't say I'm going to use absorption method. When I reach at this point, yes,
if you had x union and then inside the x did not have the complement, can we use absorption method?
you mean this, right?
Yes, exactly that.
Yes. Still, the answer is going to be x. Do you know the reason why the answer is going to be x? Because you have got intersection here, or everything that you are going to get is like when you distribute, you are going to have this. You are going to have intersected with x, x union x. Again, it will take you back to the one we had at first, where union now will be inside, because x union x is x. So it's still, you can use distribution method that in that case. Now here, what is x intersection x complement? Guys, these are the principles that you need to know. X intersection x complement is empty set. X union x complement is universal set, which is E. You don't know about this? Do you want me to prove it for you?
Yes, we do know, sir.
Okay. So if you do, then there's no need of me wasting time. So it is now. So if you don't know that x intersection x complement is x intersection x complement is empty, you can let me know. I can prove it for you.
So, sir,
Mm.
can you just give it a brief explanation on it?
Which one?
The same one, x intersection x complement is it's an empty set.
You mean when you are solving, then you explain to them the reason why it's an empty set?
No, like I want to know how
Okay,
to do
okay,
it.
okay, no problem. So, but you understand that x union x complement is universal, or maybe I explain both.
You explain both.
So let's have a Venn diagram and let's pick numbers. You can mute your mic. 1, 2, 3, 4. Now let's have our x. X is 1. Let's say this is just x, this is y. Let's have our x. X is 1 and 2. What is our x complement? Our x complement is 3, 4. So now we want to find the numbers which are found in both x and the x complement. Do we have any?
No.
That's the reason. That's the reason why it's that's the reason why it's an empty set. Now let us also talk about the reason why x union x complement is the universal. X is 1, 2 and x complement is 3, 4. So when you're talking about union, we are writing the sets, the numbers which are found in x and x complement, which is 1, 2, 3 and 4. Not so. So 1, 2, 3 and 4, these are the numbers which are found in all the set, which is the universal E. You are now okay?
Yes, I get it, sir.
Thank you.
Thank you.
So then here we can clearly see that this is going to be x intersection y complement. Now if we union it with empty set, I'll end up with just this. So this is my answer. It can't go further than that.
Understood.
Prosper, are you here, sir? What's the answer for B? Tell me the answer. In 30 seconds, you can be able to know the answer here from the explanation I've given you. Prosper, what's the answer here? Hmm? Why is the answer? Because I'm going to use the absorption rule. So why is the answer? This one here, if we have this guy in common, it's the same as x intersected with y union y complement. Have you seen how I've dismantled this one? Or maybe we're still behind.
Sir, they were still behind. We need the explanation.
A intersection B union C. If I distribute this, do you know that? Can you mute your mic? Mute your mic. You guys can mute your mic. Okay. Okay. This is the time to kick you out. Okay. Do you guys understand that if I distribute this, it's going to be A intersection B union A intersection C? Do you know about this?
Yes. We do.
So if this A appears twice, it's the same as it's going to be outside. Intersection appears twice, it will be here. So if I want to take it back here, I'll say A intersect it, open brackets, then I'll get B and C, then I put union. So it's B union C. It's the same here. X appears twice. X intersection appears twice. Intersection, there is Y here and this guy, then union will be in between. So Y union Y complement. What's the problem now? We are now good to go.
Yes, sir, we are good to go. Thank you.
What is Y union Y complement? I talked about this recent just after I think few minutes ago. What is Y union Y complement? Universal set. Oh, yeah. Why the empty set? A intersection A intersection universal is A. So what is X intersection universal?